Hello everyone. In this video, we're going to be solving a Diophantine equation, which means an equation with integer solutions. So we have xy equals x plus y. So we're looking for two numbers whose product equals their sum. Can we find those numbers? Let's go ahead and give it a try. And by the way, I'll be introducing two methods. Let's start with the first method. First of all, I want to put these two together. So let's go ahead and divide both sides by xy. So x plus y divided by xy equals xy divided by xy. Of course, I'm assuming that x and y are not 0, but you got to be very careful here because you will run into some complications. But anyways, this becomes 1 as long as they're not 0. And from the left-hand side, we get something interesting. 1 over x plus 1 over y equals 1. Unit fractions, or is it called Egyptian fractions? Something like that. So we're looking for unit fractions whose sum is 1. Can we find them? Sure, we should be able to. The easiest case is probably 1/2 plus 1/2, right? Because 1/2 plus 1/2 is 1, as you know. Nobody said x and y would have to be different, right? They can be the same. And if x and y are equal, this equation is satisfied by 2, 2. But the million-dollar question is that the only solution, right? Is that it? So let's go ahead and find out. Suppose x is less than 2. Well, if x is less than 2, it can be 1, and you can always test it out. If x is 1, then 1 over y needs to be 0, which is problematic. If x is 1, and you can test it in the original equation, it's probably better. Suppose x is 1, then you get something like this. Let me show you what happens here, something interesting happens. If x is 1, because we said that, okay, what if x is less than 2, right? If x is 1, then we get y equals y plus 1. Isn't that interesting? This equation will never be satisfied. No matter what kind of what kind of set you choose, complex, real, whatever, because 1 more than the number, right? You're basically saying that this is the same as 0 equals 1, which is not true at all, right? Never. So x cannot be 1. For the same reason, y can't be 1 because of the symmetry, right? And if x or y is going to be less than 2, it can't be 1. Can it be 0? Maybe. We'll get to that later. But let's assume on the contrary. What happens if x is greater than 2? Because we know that x equals 2 is a solution and 1 didn't work. Let's go ahead and explore something greater than 2, right? Okay, so we're going to do a little bit of algebraic manipulations, okay? So if x is greater than 2, and obviously it's going to be positive in that case, 1 over x is going to be less than 1 over 2. Would you agree? And then if you add 1 over y to both sides of this inequality, you'll get something like this. 1 over x plus 1 over y is going to be less than 1/2 plus 1 over y. But why did you do this? There's a good reason why I do this, because we know that this is equal to 1. I mean, it's given, right, in the original equation. Not in the original one, but this is something we got after we divided both sides by xy, right? So what does that mean, though? Take a look. Flip the sides. You'll get 1 over y plus 1/2 is greater than 1. Subtract 1/2. 1 over y is greater than 1/2. And that implies y is less than 2. So we arrived at something pretty interesting. If x is greater than 2, then y has to be less than 2. That's interesting. So can x be 3 then? And y could be 1? You can always test it out, right? So for example, take this equation. Suppose x is equal to, or let me see, what was I thinking? Oh, x is greater than 2, right? Okay, so if x is greater, let's say x is 3. Then 1 over 3 plus 1 over y is equal to 1. This implies that 1 over y is equal to 2/3. That means y needs to be a fraction. But it can't be, because it's supposed to be an integer. So if x is 3, we run into a problem. Actually, for any value greater than 2, you run into a problem. Houston, we have a problem. And do you know why? Let me tell you. Isolate 1 over y here. You're going to get 1 minus 1 over x. And write this as x minus 1 over x. And from here, you can find y as x over x minus 1. So you kind of need to divide an integer by 1 less than that integer. Can the result be an integer? Probably not. I mean, think about it. 3 over 2, 4 over 3, 5 over 4. These will never be an integer. Yes, as x approaches infinity, the limit would be 1, but we're not talking about limits here. Come on, this is not a calculus class. This is not a class either, obviously, but you get the idea. But wait a minute, 2 over 1 works. Yay. But that just means x is 2 and y is 2, and we already know that, so nothing new about that, right? But at least we verified that solution one more time. So this probably means that there are no other solutions, right? But let's go ahead and take a look at the second solution, because I think second solution is going to teach you something important, in case you didn't know this already, because we're going to invoke someone. Are you ready? Okay. So we're going to invoke Simon. You know, what does that mean? So let's go ahead and go back to the original equation. xy is equal to x plus y. Let's not do any crazy division stuff, because dividing is dangerous, right? So sometimes. Let's go ahead and use subtraction. It's safer. And let's put everything on the same side. And then you start factoring. Let's factor the first two terms. And then this is where Simon is needed. So let's go ahead and invoke Simon. Simon, can you come? There's a method called Simon's favorite factoring trick, which is also abbreviated as SFFT. But I just call it Simon. Every time I say Simon, I'm using this method, okay? So what do we need to make this work? So a little bit of abracadabra, mathematical touch. We do need to add 1 to both sides. You know why? Because if you factor out a negative 1 here, you realize that y minus 1 appears as a common factor. Ta-da! It's mathemagic, right? Now we can factor this as x minus 1 times y minus 1 equals 1. This is awesome, don't you think? Amazing, mind-blowing. Why? Because you're getting 1 by multiplying two integers. If x and y are integers, x minus 1 and y minus 1 are also integers. And the product of two integers can be 1 only if both integers are 1 or both are negative 1. There is no other case, right? That's the good thing about 1, being oneness, right? So we have two systems then. X minus 1 equals 1, y minus 1 equals 1, or x minus 1 equals negative 1, and y minus 1 equals negative 1. Let's go ahead and solve each system separately. Obviously, this gives us 2, 2, and this gives us 0, 0. Ta-da! This is a secret I've been keeping from you guys. Sorry about that. I just want you to hang around, stick around, and wait until the end, because I'm going to tell you something that is really cool. But you get the idea, right? 0, 0 is a solution, and you can easily verify that. Obviously, this was probably one of the most trivial solutions, because 0 plus 0 is equal to 0 times 0. But not only that, 2 plus 2 is equal to 2 times 2, which is amazing, because no other integer will satisfy this besides 2 and 0 have this super special property. And you know what? 2 is so special that even when you do like 2 to the power 2, it'll give you 2 plus 2, which is also 2 times 2, okay? Let's go ahead and look at it from another perspective. We could also take it from the first method. Remember when we got y equals this? So let me go ahead and take it from there. Y equals x over x minus 1. This is the bonus part, okay? I can now go ahead and manipulate x a little bit, like to make it look like the denominator. Write it as x minus 1 plus 1. The ones cancel out, but don't cancel them, because now we're going to split the fraction. This is 1 plus 1 over x minus 1. And it's just amazing. You know why? You know why? This is why. Because if you subtract 1, you'll get y minus 1 is equal to 1 over x minus 1. And then y minus 1 times x minus 1 equals 1. Therefore, you'll arrive at the same equation. Wow, isn't that mind-blowing? And guess what? This brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video, like probably tomorrow. Until then, be safe, take care, and bye-bye.